electrons in different shells in Valency. Bohr and Murray suggested that electrons are arranged around the nucleus in the shells of an atom according to a set of rules. The maximum number of electrons which can be accommodated in a shell is given by a formula 2n square, where n is the number of orbit or shell or energy level. The K shell means first orbit or first energy level, so n is equal to 1. K shell can accommodate 2 multiplied by 1 square, which is equal to 2 electrons. L shell means second orbit or second energy level, so n is equal to 2. L shell can accommodate 2 multiplied by 2 square, which is equal to 8 electrons. Third orbit or M shell can accommodate 2 multiplied by 3 square, which is equal to 18 electrons. Fourth orbit or N shell can accommodate 2 multiplied by 4 square, which is equal to 32 electrons. The maximum number of electrons that can be accommodated in the last, that is the outermost orbit, is 8. If the outermost shell is the first shell, that is the K shell, it cannot accommodate more than 2 electrons. The outermost shell always has 8 electrons due to the exceptional stability of arrangement of electrons. To write the electronic arrangement of an atom, a few steps should be followed. First step is to find out the proton number of the atom from the periodic table. The second step is to find the number of electrons of the atom. For a neutral atom, the number of electrons is the same as the number of protons. The third step is to arrange the electrons in shells. Electrons occupy the shells close to the nucleus first. Electrons only start occupying a new shell when the previous one is occupied. Hydrogen is the lightest atom. It has 1 proton and 1 electron. The protons and the electrons are represented as balls. This electron can be accommodated in the first shell or K shell. Helium is the next element with the atomic number 2. It has 2 protons and 2 electrons. Both electrons are accommodated in the first shell. Lithium has atomic number 3. That is, it has 3 protons and 3 electrons. Out of these 3 electrons, 2 electrons are accommodated in the first, that is the K shell, and the third electron goes to the second shell, that is L shell. Let us take an example of oxygen atom. Oxygen, atomic number 8, has 8 electrons. 2 in K shell and 6 in L shell. L shell can accommodate only 8 electrons. If there are more electrons, they go to the next higher shell, that is M shell. M shell is the third orbit. Let us discuss electronic arrangement of a chlorine atom. The proton number is 17. The number of electrons in a chlorine atom is 17. The 17 electrons are arranged as 2 in the first shell, 8 in the second shell, and the remaining 7 in the third shell as shown. The electron arrangement of the chlorine atom can be written as 2, 8, and 7. The electrons add up to the right number, that is, in this case, they are 17. When we reach potassium, the electron configuration according to 2n square rule should be 2, 8 and 9. but it is shown to be 2, 8, 8 and 1. Because the outermost shell is stable only if it has maximum of 8 electrons, though it can accommodate more number of electrons. So, electronic configuration of potassium is 2, 8, 8 and 1, because having 9 electrons in M shell decreases the stability of potassium ion. Similarly, for calcium, Z equals 20, having 20 electrons, the electron configuration is 2, 8, 8 and 2, and not 2, 8, 10. Let us now learn about valence electrons. Valence electrons are electrons found in the outermost occupied shell of an atom. This shell is also called valence shell. The number of electrons present in the last incomplete shell is responsible for chemical properties of an atom. The remainder of the atom, that is, the nucleus and the inner shells, constitute the core and are normally not responsible for chemical properties of an atom. You can see the electronic arrangement of hydrogen. It has only one valence electron. When it loses one electron, it becomes a hydrogen ion, that is, positive ion. More about positive ions or cations. A positive ion gets formed when in case an atom loses one or more electrons. For example, the electronic distribution in sodium is 2, 8 and 1. It loses one electron to form a positive ion with electronic distribution 2 and 8. Since in an ion, the number of electrons 2 plus 8 is 1 less than the number of protons, that is 11, it has 1 unit positive charge. For example, the electronic distribution in magnesium is 2, 8 and 2. It loses 2 electrons to form 2 positive ions with electronic distribution 2 and 8. Since in an ion, the number of electrons 2 plus 8 is 2 less than the number of protons, that is 12, it has 2 units positive charge. For example, the electronic distribution in aluminium is 2, 8 and 3. It loses 3 electrons to form 3 positive ions with electronic distribution 2 and 8. Since in an ion, the number of electrons 2 plus 8 is 3 less than the number of protons, that is 13, it has 3 unit positive charge. Negative ions or anions. A negative ion or anion is formed when atom of an element gains 1 or more electrons. Let us have a look at electronic distribution of nitrogen. N is equal to 2, 5 electrons. It gains 3 more electrons to form a negative ion. Since in an ion, the number of electrons, 3 plus 5, is 3 more than the number of protons, it has 3 unit negative charges as shown on the screen. We call this a nitride ion. Now the electronic distribution of oxygen. O equals 2, 6 electrons. It gains 2 more electrons to form a negative ion. Since in an ion the number of electrons 2 plus 6 is 2 more than the number of protons, it has 2 units negative charges as shown on the screen. We call this an oxide ion. Observe the electronic distribution of fluorine. Fluorine equals 2 and 7 electrons. it gains one more electron to form a negative ion. Since in an ion the number of electrons, 1 plus 7, is 1 more than the number of protons, it has 1 unit negative charge as shown on the screen. We call this a fluoride ion. Fill in the gaps in the following incomplete table. Number of protons equals atomic number 9. Number of electrons equals number of protons equals 9. Name of element equals fluorine. Atomic number equals number of protons equals 12. Number of electrons equals number of protons equals 12. Name of element equals magnesium. Number of protons is equal to number of electrons equal to 17. Atomic number is equal to number of protons equal to 17. Name of element is equal to chlorine. Let us revise. Elements are identified by their atomic numbers. No two known elements can have the same atomic numbers. Protons and electrons are equal only in a neutral atom. In cation, electrons are less than protons. While in an anion, these are more than the protons. According to Bohr-Bury scheme, the electronic distribution in the first 4 shells is K has 2 electrons, L 8, M 18 and N 8. Outermost shell cannot have more than 8 electrons and K shell can have a maximum of 2 electrons. If atomic number of an element is known, arrangement of electrons in its atom can be written. The outermost shell of an element is called valence shell because its valency is related to the number of electrons present in the shell. The ion carrying positive charge is called cation. The ion carrying negative charge is called anion. When an atom changes into ion, number of protons remains same. Number of neutrons remains the same. Number of electrons always changes.